Hi everyone. Today we're going to be completing our notes on section 4-4, linear inequalities in two variables. I want to start off with this warm-up. Let's identify a possible solution for the inequalities below. Question A says x less than 10. So any possible solution would be any number less than 10. So an example would be x is equal to 9, or 7, or -5. For part B, here we have all of the values greater than or equal to -3. The inequality here would be x greater than or equal to -3. So solutions to this could be anything on the right-hand side here, anything shaded in red. So 0, 5, or even something like 1 million. I'll say 10. All right. For this last part here, we have every value less than 0. So x less than 0. So possible solutions could be anything for like -3, -5. Um, let's consider the number 0. Is 0 a solution here? The answer is no, 0 is not a solution here. The reason why is because this point is not filled in, so we do not want to include this in the solution set. Whereas something like letter B, where we had it included, this dot was shaded here. So in fact, let's go ahead and add -3 is also a solution. Okay. So let's see, what is a solution outside a system of equations? If we have a simple line, then any point on the line is a solution, right? So if we're looking at this line here, y equals 1/2 x minus 3, any point on this line is a solution. Let's choose a point that is on the line. So for example, -4, -5. And let's see what happens to the equation. So the equation here, we would plug in our x, y point. So we'd plug in -5 in for y, and we would plug in -4 in for x. So what we get here is the equation -5 is equal to 1/2 times -4 minus 3. Okay, let's go ahead and evaluate the right-hand side. So we have 1/2 times -4 is -2, and then minus 3. And we bring down our equals -5. And we have to check, is -2 minus 3 equal to -5? It sure is. Let's choose a point that's not on the line, 2, 3. So again, this is the xy ordered pair. We plug in 3 in for y, so we have 3 is equal to 1/2 times 2 minus 3. Okay, when we plug this in, evaluating the right-hand side, we get 1/2 times 2 is 1 minus 3. And then when we subtract 3 from 1, we get -2. So this is not true. These are not equal. Okay, so we just considered the points -4, -5, and 2, 3 would be up here. Okay, so a point on the line and a point off the line. So therefore, a solution to a linear equation is any point on the line, and points off the line are not solutions to the linear equation. So for linear inequalities, the difference is instead of having an equation, we have an inequality. So those are our greater thans, less thans, our greater thans are equal to, and our less thans are equal to. The solution includes points that are also off the line, right? So we're considering points that are not only on the line, but also anything that is greater than or less than. So where the graph is shaded, this is going to show the points that are part of the solution set. Any point that's inside the shaded region will make the inequality true. So let's see what this looks like here with this inequality here. Y is greater than or equal to -3x plus 3. So let's choose the point 4, 2. So this would be the point in the shaded region here, 4, 2. If we test that, again, the xy point on the in the shaded region, we would plug in 2 in for y, and then is greater than or equal to -3 times x. Well, x is 4, and then plus 3. So evaluating the right-hand side of this inequality, we get -3 times 4 is -12, and then plus 3. We get 2 is greater than or equal to, well, -12 plus 3 is -9. And so we have to ask ourselves, is 2 greater than or equal to 9? Yes. -9? Yes, it is. 2 is greater than or equal to -9. So now let's choose a point that's not in the shaded region. So -2, 1. That point is right here. If we were to test this point, let's see what happens to the inequality. So we're going to plug in x, y. So we're going to plug in 1 in for y is greater than or equal to negative 3 times x, which is negative 2, and then plus 3. We get 1 is greater than or equal to. Negative 3 times negative 2 is positive 6. And then bring down our plus 3. When we evaluate 6 plus 3, we get 9. And then we have to ask ourselves, is 1 greater than or equal to 9? The answer here is false. This is not true. Okay? Whereas when we chose a point in the shaded region, that was true. Okay? Because this inequality here on the right is false, we know that the point negative 2, 1 is not part of the solution set because it led to a false inequality. Okay? If the inequality had a dashed line, so here we have a solid line, if it was dashed, then points that are on the line would not be included. But because this is a solid line, the points on the line are included. Okay, so let's see what this looks like graphically. Using this graph below, let's see whether or not these ordered pairs are solutions to the linear inequality. So we'll start with negative 2, 0. If I were to plot that point, it's just to the right of the line. So this is in the shaded region. This is a solution. Negative 3, negative 2. So negative 3, negative 2 is not in the shaded region. So this is not a solution. 5, 3 is deep in the shaded region. We're good there. That is a solution. Negative 4, 3 is on the dashed line. Because it's on the line and the line is dashed, we do not include this in the solution set. That has to do with it being dashed. If the line was solid, again, this would be part of the solution set. But because this dash is not. Okay, so 0, 5, we have up here on the y-axis, that is a solution. All right, so let's go ahead and graph some inequalities. Here, let's go ahead and graph y is greater than 3x minus 2. Step 1 is to just graph the line just like it's an equation. So using slope-intercept form, if it's in standard form, use those x and y intercepts. If it's in point-slope form, use that slope and that point. Well, I notice that this is in slope-intercept form, where the slope is equal to 3 and the y-intercept is equal to negative 2. Okay? I'm going to rewrite that slope as a fraction. That helps me graph it. So let's go ahead and graph this. We start with the y-intercept, negative 2. And from there, we can plot our other points using the slope. So we're going to go up 3 and to the right 1. If you have, like the side of your ID, a calculator case, a straight edge, a ruler, anything like that, it's helpful to graph these lines. I am graphing digitally, so it's a little bit hard for me to draw a straight line, but hey, that's not too bad. All right. And you know what? I accidentally drew that a little bit too fast. So step 2 is going to be to connect our points. We're going to use a dashed line if it's a greater than or less than, or I should read that, so less than or greater than. And then we use the solid line if it's less than or equal to or greater than or equal to. In this case, we have just greater than. So this is going to be a dashed line. So if you drew it too fast like me, you might have to erase it a little bit. But this is a dashed line. So I'm going to draw this as the dashed line. Okay. Now this is still a line, so don't forget those arrowheads. This does extend infinitely in both directions. And then step 3 is to find the solution. Choose a point not on the line and plug it into the equation. We have to figure out which side of the graph to shade. Okay? Most often, the easiest point to choose is going to be 0, 0, and that's going to be my recommendation for this line. If the line crosses through 0, 0, then you're going to have to choose another point that's not on the line. In this case, 0, 0 is not on the line, so it's a great test point. So I'm going to test 0, 0. Okay, and we're going to plug it into the inequality. So y is greater than 3x minus 2. So we're going to plug in 0 for y and plug in 0 for x. So 0 is greater than 3 times 0 minus 2. And we want to see whether or not this is true or false. So evaluating the right-hand side, we get 0 minus 2. And we know 0 minus 2 is negative 2. So we get the inequality 0 is greater than negative 2. Is that true or is that false? Well, yes, that's true. 0 is greater than negative 2. Therefore, if you get a true statement, we're going to shade the side of the graph that contains the test point or contains the point that, that we just tested here. So 0, 0. Okay, so because we got true when we tested 0, 0, we want to shade the side that contains 0, 0. Okay, so shade in the whole graph, get all the way up to that line, get nice, good shading, right? We want it to be nice and full. So I'm going to shade it real nice so that it's easy for me to tell which side we're shading on. Okay, try not to cross the line here. So try to get real close to the line, but don't cross it. If the inequality is false, so let's talk about the opposite. If you get a false statement, so suppose this inequality said 0 is less than -2, that would be false. We would shade the opposite point, the point not containing our test point. Okay, so let's try a few examples. Graph 6x minus 3y is less than or equal to -12. Okay, so I noticed that this is in standard form, ax plus by equals c. So let's go ahead and graph this using x and y intercepts. So I'm going to start by finding the x-intercept, which as a reminder is where y is equal to 0. I'm going to plug this into the equation, and yes, I'm going to treat this like an equation because we're solving for intercepts. So 6x minus 3y is equal to -12. We're going to plug in 0 in for y. So I'm going to replace that y with 0 and then solve for x. So we have 6x minus 0 is equal to -12. And then we get 6x is equal to -12. Dividing both sides by 6, we get x is equal to -2. So therefore, the coordinates for the x-intercept is -2, 0. The y-intercept, as a reminder, is where x is equal to 0. So we're going to plug in 0 in for x, and we're going to solve for y. So we get 6 times 0 minus 3y is equal to -12. We get 0 minus 3y is equal to -12, or -3y equals -12. Dividing both sides by -3, we get y is equal to +4, giving us the coordinates for the y-intercept, 0, 4. So let's go ahead and plot both of those on the plane, -2, 0 and 0, 4. And then we're going to connect our dots with a solid line. We know it's solid because we have less than or equal to. Okay, so go ahead and use your ruler, use your straight edge, your ID, your calculator case, any straight edge that you have. Make sure those lines are straight, and don't forget those arrowheads on both ends of the line. All right, so in order to determine the shading, we're going to test our point that's not on the line. 0, 0 is not on the line. So we're going to plug in 0, 0 into the inequality. So we have 6 times 0 minus 3 times 0 is less than or equal to -12. We have 6 times 0 is 0, minus 3 times 0 is 0, and then is less than or equal to -12. We get 0 is less than or equal to -12. Is that true or false? That is false. 0 is greater than -12. So because this is false, we're going to shade in the side opposite of 0, 0, the side not containing 0, 0. Okay. All right, so number 3, let's go ahead and graph this inequality here. I notice it's already in slope-intercept form, where the slope is -2/3, and the y-intercept is -5. So we can start by plotting the y-intercept at -5, and then finding other points using the slope, down 2 and to the right 3. I'm going to find some points to the left by going up 2 and to the left 3. And I know that this line, step 2, is going to be dotted. And the reason why is this not equal to. It's just strictly less than. So I'm going to plot this and graph a dotted line. Okay. Now I'm going to choose my test point, a point not on the line. Let's choose 0, 0, and see if the inequality holds true. So we have 0 is less than -2/3, x minus 5. We get, not x, that is 0. So we're plugging in 0 for both x and y. So we have 0 is less than -2/3 times 0 minus 5. So if 0 is less than 0 minus 5, or 0 is less than -5. Is that true or false? This is false. 0 is greater than -5, so therefore we're going to shade in the side not containing 0, 0. All right, go ahead and flip the page. So here we have x is greater than -2. So this looks similar to the equation x equals -2, which we know x equals a number is the equation for a vertical line. So yes, this is going to be a vertical line at -2. And I know that it's going to be a dotted line because we don't have that or equal to part. So dotted line at -2. And then we're going to go ahead and test 0, 0. Plugging in 0 in for x, we get 0 is greater than negative 2. That is true. 0 is greater than negative 2, so we're going to shade in the side containing 0, 0. Okay. All right, so number 5, what's the solution to the inequality? Y is less than or equal to 7. Similarly to the last one, we have y. This looks similar to y equals 7, the horizontal line. So we have the horizontal line here for the inequality. Y is less than or equal to 7. This is a solid line because we have that or equal to piece. Let's go ahead and test 0, 0 to see our shading. So 0 is less than or equal to 7. That is true. 0 is less than 7. So let's go ahead and shade in the lower half of this graph, everything less than that line. All right, number 6, which inequality is shown by the graphs below? We have got the vertical line, so I know it's going to be x in some relation to a number. So I notice that that number is negative 1. So we're looking at x greater than or equal to negative 1. Okay, I know it's greater than because it's everything to the right of negative 1. I know it's or equal to because their line is solid. Okay, we can always check our answer by plugging in the test point 0, 0. Plugging in 0 is 0 greater than or equal to negative 1. Yes, that's true. So we do want to shade in the side containing 0, 0. All right, letter B, I know that we have a y-intercept of 3, and we have a slope of negative 3/4. We go down 3 into the right 4. All of our inequalities have that slope and y-intercept, so it's a matter of which inequality we choose. This line is dotted, so we can eliminate the ones that say or equal to A and B. Okay, so now it's just a matter of if it's less than or greater than. So what we can do is consider the shading. Let's go ahead and choose the test point 0, 0 and plug it into the inequality here. So 0 and then some relation to negative 3/4 times 0 and then plus 3. Okay. If we were to evaluate the right-hand side, we get 0 plus 3 or just 3. The left-hand side is just 0 each time. Now, we are shading the side not containing 0, 0. So I want this inequality to be false. So I'm going to say something ridiculous like 0 is greater than 3, something false. We know that 3 is greater than 0, but I want this inequality to be false. So that tells me that the inequality is greater than, or letter D. Okay. Another indicator is that greater than is going to represent shading above. This is generally true. So shading above the line, whereas less than will be shading below the line. And I'm putting in quotes because it's hard to say above and below when we're looking at slanted lines. I mean, you can kind of see in this problem here that it's above in this region over here. So I put that in quotes just to kind of have it's more of a check for you, like to check that you are shading in the correct region. You should always do a test point. Okay, letter C. Here we have a y-intercept of 2 and a slope of up 2 to the right 1. So slope is 2. The y-intercept is 2. So we have y, some relation, 2x plus 2. And we want to contain the point 0, 0. So if we're going to plug in, so test 0, 0. If we were to plug in 0, 0, we would want this inequality to be true. So we'd have 2 times 0 and then plus 2, or 0 plus 2, or 2. We want this to be true. So I'm going to go ahead and say less than here, because 0 is less than 2. And here we can kind of see that the shading is beneath the line. Okay. All right, last one here. We have a y-intercept of negative 3. And we have a slope. I see another point right here. Our slope is equal to negative 4 over positive 2, which reduces to negative 2. So we have y, some relation, negative 2x minus 3. So let's test 0, 0. So if we plug in 0 in then some relation, negative 2 times 0 minus 3. If we were to evaluate the right-hand side, we get 0 minus 3 or negative 3. Now we want this inequality to be false because we're shading in the side opposite of 0, 0. We don't want to contain it. So again, I'm going to say something ridiculous like 0 is less than -3. Okay. We know that 0 is greater than -3, but we want this to be false. So we have less than, and that's going to be our inequality here. All right, so this has been our notes on 4.4, graphing inequalities in two variables. We're going to get a lot of practice on this, so we'll see you tomorrow. Goodbye, everyone.